In this next video, we're going to focus on this idea of significant figures, and the title for this is Rules for Counting Significant Figures in Recorded Measurements. So what it's going to be is that we just did a whole bunch of sig fig work when we had to record the measurement down. So we were like, well, what did we write down? What's significant? Whereas now it's going to be more, you're given a data that's been recorded from a measurement, and you have to know how much significance that number is carrying. So there's a number of rules. I've tried to break it down into this table to sort of help you understand where to go. And we're going to be going through leading zeros, which are zeros in front, in between zeros, which are what I call captured zeros, they're between numbers, non-zero digits, and then trailing zeros. So the first one we're going to look at is non-zero digits. Non-zero digits are always significant. You don't have to question them. So if you have a number like 4.76, this is read to 2 decimal places of precision. This 6 would be an estimate, and we would call this 3 significant figures. Now what we get to do is we get to introduce zeros. So non-zero digits has 1 rule, and zeros have 4 rules. So let's start with our leading zeros, because they're easy, because they're never significant. We kind of treat them as placeholders. If anybody's done any work with scientific notation, you'll know that we never write these in our numbers, so they are not significant. So in other words, these zeros don't count, but these non-zero digits do count. So this would be 2 significant figures. In between zeros are zeros that are captured. They're within the number, and they are always significant. I mean, you can't write 4076 without that 0 in there, so we just count them. So we'd have 1, 2, 3, 4, 5, 6 significant figures, counting the in-between zeros as well as the non-zero digits. What did I say? 6. This one I tried to make a bit of a combination of the two. So this one has some leading zeros as well as some in-between zeros. And so the leading zeros are never significant, and the in-between zero always is. So this would be 1, 2 non-zero digits plus my captured digit would give me 3 sig figs. The next section we're going to look at is our trailing zeros. And this is probably the one people kind of have the most confusion with, because there's 2 scenarios. There is scenario 1 where you have trailing zeros with a decimal, and scenario 2 where you have trailing zeros without a decimal. The nice thing is that there's only 1 rule for each. When there's a decimal, they're significant. When there's not a decimal, they're not significant. So for example, if I have a number like 3200, but with a decimal on the end, that is showing significance, versus this number down here that's 3200 without the decimal, it's not showing the significance. So for example, this one, it's saying, hey, my measurement was exactly 3,200. Whereas this one's like, well, I don't know, maybe around 30,200, maybe 3,205, maybe 3,210. I have no idea. So this decimal place shows that it is significant. If you're wondering, if we went back to an actual measurement to show you what that would look like, remember this one where we were like, oh, this one's 20 because it's somewhere between 0 and 100. This is that 1 sig fig. That is that 0 not counting. Whereas if this rod had been exactly here, right? Here we were allowed to write down the 20, and then we were estimating the 1. So this one we said 21, 22, 23. Whereas if it had been right on that line, I could have said, hey, this is exactly 20. So the difference is whether you're estimating the 2 in the 20 or whether you are estimating the 0 in the 20. That'll determine whether you have, for this one, 1 sig fig versus 2 sig figs. And then for this one down here, whether for this one you have 4 sig figs, or if it's written like this, you have 2 sig figs. So those trailing zeros only count if there's a decimal. So if you have 304.00, this is 5 sig figs. You have 2 non-zero digits, 1 in between 0, and then 2 trailing zeros that are significant. This measurement was exactly 304.00. This one here, we have 302.0900. You'd have 1, 2, 3, 4, 5, 6, 7 significant figures. And then again here, when we don't have the decimal, you can't write any of these digits. You can kind of just write these hundreds or tens or whatever it is. This one, we have 2 non-zero digits, 1 in between 0, and we would say that this is 3 sig figs. The last one I'll talk about is this weird, I shouldn't say weird, it's not weird, this one that's exact numbers. So there's things where when you're measuring, you actually don't put 0.000, but you mean 0.000. For example, if I tell you you have 4 cars, you're not going to have 4.2 cars, right? It's like people. You're not going to have 4.4 people and be like, well, we have that one arm of the person in the picture or whatever it is. You would just say, hey, there's either 4 people or there's 3 people or there's 5 people, right? There's 4 cars or there's 3 cars or there's 5 cars. So for this one, we count this as an infinite number of sig figs. Don't worry about this too much until we do operations with significant figures, or calculations with significant figures, but just know that if anything's an exact number, I can't be any more precise, then you can count it as an infinite number of sig figs. And this one I can find a little bit contentious with a few ones. You'll sometimes find these called cardinal numbers as well. All right, so I have 9 examples here that I want you to try, and I really, really, really want you to pause the video right now and give these 9 a try. If you're too nervous to write down a number, don't write it down, think it in your head, but you've got a pencil, right, or even a pen, write it down. If you're wrong, cross it out. Think about, why am I wrong? So pause the video now. Okay. I'm hoping you pause the video. So I'm going to go through and just tell you the answers. So this one has 4 sig figs, right? Non-zero and an in-between. This one has 3 sig figs. This leading 0 does not count. For this one, you also have 3 sig figs because this trailing 0 without a decimal does not count. For this one, we have 1, 2, 3, 4, 5, 6 sig figs because all of the zeros count. For this one, these leading zeros do not count, so this one has 3 sig figs. This number, this 0 does not count. It's kind of similar to this question above. In fact, actually, I'm going to put I'm going to put that decimal there. So if you didn't have that decimal there before, it was 3 sig figs, but with this decimal here, it was 4 sig figs. Sorry, sometimes I notice things when I make the video. All right, so for this next one, you have 5,000 written down. 5,000 with no decimal places. This is going to be 1 sig fig. This one, when we put the decimal place on the end, all of a sudden we have 5 sig figs. And then this last one, 1 minute. This one would be arguable, and I kind of debated whether I should put this one on or not. I'm going to count this an infinite number of sig figs because someone says that you're going to run for a minute. We're going to assume that you're running for exactly 1 minute, right? And so instead of writing, 60 seconds with decimal point, 0.00000, we're just going to say exactly 1 minute. All right, so hopefully those made sense. And the next thing we're going to do is round to a certain number of sig figs. So I've got a bunch of numbers written down. This one has 5 sig figs, this one has 6 sig figs, this one has 6 sig figs. And what we're going to do is we're going to round these to a specified number of sig figs. Because what's going to happen is that you are going to be doing calculations in physics, and you're going to get an answer with a ton of significant figures to it, but you're going to be limited by the significant figures in your question, and you're going to be asked to round. So we're just going to start practicing that now. So if I was going to take this number and I was going to round it to 4 significant figures, I would be rounding the 5. So we have 78.657. I'm going to round to 4 significant figures. So I'm going to count from the left, which means I'm going to be rounding the 5. The rule says if the number to the right of the number you're rounding is greater than 5, you're going to round up. And if it's less than 5, then you're going to keep it the same. So since this one's a 7, I'm going to write this as 78.66 to 4 significant figures. If I want to take this number again, but this time I'm going to round to 3 sig figs, I'm going to keep these 3. And now, because the number to the left of the 6 is a 5, I'm going to round up again. So this one would be 78.7 now to 3 sig figs. If I was going to do 2 sig figs, again, I write that whole number down. I'm going to keep just these 2. And so the 6 is going to make my 8 round to a 9. So to 2 sig figs, this number would be 79. And then lastly, to 1 sig fig, I've got 78.657. I'm going to be rounding the 7. Because there's an 8 beside it, it's going to round to an 8. But I can't just write 8. 8 is a very different value than a 78, so then I put a 0 there to keep it as 1 sig fig, but keep its place value, right? So 78 would round to 80. All right, so if you understand that, you could try these next two questions on your own, entirely up to you. Or you can watch another one and do it with me, or whatever you want to do. So this one, we're going to go to 4 sig figs. So again, I like to write the number out because I do like underlining what I'm rounding. Okay, so if I'm going to do this one to 4 sig figs, because the number here is a 4, I'm not going to round up. I'm going to keep it the same. So I'm going to write 2140. But then to write this as 4 sig figs, I have to put the decimal place after. Okay. This next one, we're going to go to 3 sig figs. So 2140. My 4s always turn into 9s. 0.46. I'm going to round this one to 3 sig figs. So I've got 214. But again, I need that 0 as a placeholder, but this is 3 sig figs. So the one before I put the decimal place there, this one I don't put the decimal place here. 4 sig figs, 3 sig figs. Now let's go to 2 sig figs. So 2140.46. We're going to round this to 2 sig figs. So again, I'm going to keep that 1 the same, so it's going to be 2100 to 2 sig figs. And then lastly, to 1 sig fig, I've got 2140.46. I'm going to just keep this 2 because it's a 1 beside it. It's going to stay the same, but I'm going to fill in the rest with zeros. So 1 sig fig, 2 sig figs, 3 sig figs, 4 sig figs. I noticed when I was doing these, I was in a real pattern. These ones all rounded up and these ones all stayed the same. Hopefully in this one, I've done a little bit of a combo. We'll see. Okay, so for this one, we have 560.987. So I'm going to round to 4 sig figs. Ooh, I made this one tricky. So because the number next to the 9 is an 8, it's going to round up to a 10. So I'm going to have 561.0. So I need that 0.0 to keep it as 4 sig figs, but the 9 rounded to a 10. Now we're going to go to 3 sig figs, so 560.987. We're going to round this to 3 sig figs, so it's going to be 561. Then we're going to round to 2 sig figs, 560.987 to 2 sig figs. Because the number next to the 6 is less than a 5, I'm going to keep this as 560. And then lastly, to 1 sig fig, 560.987. I'm going to round the 5 to a 6 and put some zeros after it. Now, if anybody found that really hard, like they weren't sure when to put zeros and when to not, what we're about to learn is scientific notation. Scientific notation's nice because when you write a number down, they're all significant. So if this kind of blew your brain, scientific notation will help you write your answers a little bit easier.